Morning, everyone. Welcome to Learning Academy Foundation from Mr. Andrea. Today, we embark on a journey through one of the most elegant frameworks in science, a table that doesn't just organize elements, but reveals the hidden harmony of creation. I'm speaking, of course, about the periodic table. Begin with the visionary, Dmitry Mendeleev, the Russian chemist who in 1869 dared to arrange the known elements not only by their weight alone, but by their properties. He arranged the elements in order of increasing atomic mass. When the elements are arranged in order of increasing atomic mass, those that had similar properties occurred in a repeating pattern. His table was more than a list. It was a prophecy. Mendeleev noticed patterns in chemical behavior when elements were arranged increasing atomic mass. You can see a gap between the calcium and the titanium, for example. He left gaps in his table, boldly predicting the existence and properties of elements yet to be discovered, like gallium and germanium. So Dmitry Mendeleev in 1869 published the first periodic table by arranging cards of elements by their properties, broke the trend of arranging by mass number to have properties aligned. For example, iodine after tellurium. Boldly said that some masses had been miscalculated. Left gaps for predicted unknown elements. For example, hexasilicon is the germanium. Finally, he faced pair reversals, where elements like iodine and tellurium seemed out of order by mass but fit better by properties. Mendeleev trusted the pattern over the numbers, and he was right. He rearranged some elements so that they would line up with other elements with similar chemical properties, for example, tellurium and iodine. His table was a triumph of intuition, logic, and faith in the unseen. Today, we use a more refined version based on atomic number, the count of protons, an atom's nucleus. Hydrogen is a bit of an oddball, unique among elements with no close analog. Some tables does have it sitting alone, but most include it in the alkali metal group because, like them, it has one electron. Technetium was just a gap in the periodic table for decades, frustrating chemists who tried to find it. Like most elements, technetium can be forged in the furnaces of stars, but it doesn't stick around long enough for us to stumble upon any. When at last, Italian researchers Carlo Perrier and Emilio Segre isolated a sample, it was only because another science experiment had created some via nuclear reactions. The name comes from the Greek word for artificial, teknetos. Starting with element 84, polonium in the table, all naturally occurring elements are radioactive, meaning they are unstable and emit energy. Each element is placed by its atomic number, resolving Mendeleev's pair reversals with clarity. The table is divided into groups, vertical columns, and periods, horizontal rows. Metals dominate the left and center, lustrous, malleable, and conductive. Non-metals gather on the right, brittle, insulating, and reactive in unique ways. This modern table is not just a tool, it's a map of matter's behavior, a guide to the building blocks of life. Matter can be divided in pure, that can be divided in element like oxygen and carbon, and compound like sodium chloride and water, or mixture. Mixture can be homogeneous, like a solution, for example, cool aid, air, steel, or heterogeneous, for example, chocolate chip cookie. But what gives elements their personality? Their electrons. Electrons orbit the nucleus in shells, and the number of electrons in the outer shell determines reactivity, determines the chemical properties of an atom. So hydrogen, atomic number 1, has just one electron and one shell. Carbon, atomic number 4, has the first electron shell that can hold maximum 2 electrons, and the outermost electron shell that can hold 8 electrons. So since its atomic number is 4, it has since the atomic number is 6. Sorry, its atomic number is 6. It has 2 electrons in the first electron shell and 4 electrons in the outermost electron shell. Nitrogen, atomic number 7. So 2 in the first electron shell and 5 in the outermost electron shell. And oxygen, atomic number 8. So 2 in the first electron shell and 6 in the outermost electron shell. Then we can predict electron arrangements using atomic number. For example, oxygen, atomic number 8, has 2 electrons in the first shell and 6 in the second. So valence electrons are 6. And the periodic table itself reflects these arrangements. Elements in the same group share similar outer shell configurations, which explains their chemical similarities. These are called representative elements, and they are the elements with the s and p orbitals filling. They are groups 1 and 2, and 13 to 17. Group 18 has filled orbitals and may or may not be included. Sometimes is considered representative. They are the noble gas elements. So it's like a defined blueprint. Each element with its own role, yet part of a greater whole. Let's compare the two kingdoms of the table. Metals versus non-metals. Okay, so appearance, metals are shiny, lustrous, often silver. Non-metals are dull, non-lustrous, varied colors. Metals are hard, very hard. Non-metals indeed are soft. Metals are malleable, means that they can be bent or shaped. Non-metals indeed are non-malleable, means that they are brittle, break easily. And then about ductility, metals are ductile, non-metals are non-ductile. Heat conduction, metals are good conductor of heat as well as of electricity. And non-metals are poor conductors of heat as well as electricity. There are other differences. For example, the chemical behavior. The metals lose electrons in reactions while non-metals gain or share electrons. And the oxide nature, the metals are basic oxides while the non-metals are acidic oxides. As we guess upon the periodic table, we see more than science. We see design. The order of elements, the predictability of their behavior, the symmetry of their structure, all point to a creator who delights in precision and purpose. Colossians 1:17, it says, He is before all things, and in him all things hold together. The atoms, the electrons, the very table we study, they hold together because he holds them. So let us study with wonder, teach with joy, and live with gratitude. For even in chemistry, we glimpse the fingerprints of God. The joy of the Lord is my strength. We have to find the strength and joy in the Lord. Okay, guys, if this message sparked your curiosity or stirred your spirit, I invite you to like this video to support more educational content. Comment below with your favorite element or insight. Share this with fellow learners and believers. And subscribe for more lessons that blend science, beauty, and faith. Thank you, and may your learning be luminous. See you at the next video. Bye.